हेलो स्टूडेंट्स, हाउ आर यू? फाइन। सो आज हम न्यूटन्स लॉज ऑफ मोशन और इन शॉर्ट लॉज ऑफ मोशन में एक नया बिट ले रहे हैं, दैट इज इनर्शिया। राइट, अभी तक हम लोगों ने क्या क्या किया है? बैलेंस्ड एंड अनबैलेंस्ड फोर्सेस, कंसेप्ट व्हाट द फोर्स इज। राइट, सो आज हम लेंगे इनर्शिया। व्हाट इज इनर्शिया ऑफ एन ऑब्जेक्ट? इट इज वेरी इंपॉर्टेंट कॉन्सेप्ट टू अंडरस्टैंड। सो ये कैसे समझ सकते हैं कि सपोज एक हेवी मास है, राइट? सपोज हम एक मास लेते हैं, एक सपोज इट इज 100 kg, राइट? दूसरा एक मास है दैट इज 10 kg, राइट? दोनों रखा है सरफेस के ऊपर। अगर इस मास को आगे लेना है, हमको इसमें एक वेलोसिटी v क्रिएट करनी है, वही वेलोसिटी v क्रिएट करनी है, राइट? इसको पुल करना है, इसमें वेलोसिटी v क्रिएट करनी है। तो हमको किस में ज्यादा फोर्स लगाना पड़ेगा? ऑब्वियसली आप बोलेंगे इसमें ज्यादा लगाना पड़ेगा। व्हेन वी आर पुलिंग इट, इट इज think something is opposing the motion, right? And that depends on the mass of the object. मास ज्यादा है तो ये अपोजिशन अपने को ज्यादा मिलता है, मास कम है तो अपोजिशन कम मिलता है। हाँ, आराम से खींच लेते हैं। मास ज्यादा है तो इट टेक्स मोर फोर्स, राइट? सो कोई भी चीज ऐसी है जो कि इसके मास पर डिपेंड कर रही है। मास ज्यादा है तो वो चीज ज्यादा है, मास कम है तो वो चीज कम है, मतलब कि अपोजिशन कम है। So this is the tendency of an object which opposes the state of motion. State of motion ये एक स्टेट में है, तो कौन सा स्टेट है इसका? रेस्ट में, मीन्स वेलोसिटी इज जीरो। So it opposes the change of state of motion and this is the natural inherent tendency of an object. इसको हम क्या बोलते हैं? इनर्शिया बोलते हैं। What is inertia? It is inertia is the tendency of an object to oppose the state of change in state, oppose the change in state of motion of an object. Up of the object. Here I will write of the object. Why the object? Because I am talking about the same object. अब इसका with example you will understand better. आप सपोज एक बस में बैठे हैं, जैसे ही बस स्टार्ट होती है, you feel that you are going behind. क्यों ऐसा होता है? कि बस स्टार्ट हुई, उसमें कुछ एक्सेलरेशन आया, सो जहां जिस सीट पर बैठे हैं, सीट इज फिक्स्ड विद द बस ग्राउंड सरफेस, बेस से वो फिक्स है। तो जैसे ही बस आगे बढ़ती है, ये सीट आगे बढ़ती है। जैसे ही सीट आगे बढ़ती है, आपका लोअर पार्ट विच इज इन कॉन्टैक्ट विद द सीट, इट मूव्स। चूंकि आपकी बॉडी रिजिड बॉडी नहीं है, इसलिए बॉडी की टेंडेंसी क्या है? टू रिमेन एट रेस्ट, राइट? लोअर पार्ट मूव करता है, लेकिन अपर पार्ट इज इन टेंडेंसी टू रिमेन एट रेस्ट ड्यू टू इनर्शिया। इट अपोजेस द चेंज स्टेट ऑफ मोशन, चेंज ऑफ स्टेट ऑफ मोशन, इट इज अपोजिंग। इसलिए क्या होता है कि वो वही रहना चाहता है, वही रहना चाहता है। तो हम ऐसा फील करते हैं कि हम पीछे जा रहे हैं, एक्चुअली हम वही रहते हैं। आवर लोअर पोर्शन हैज गॉन फॉरवर्ड बट वी फील दैट आई एम गोइंग बिहाइंड। So this is the condition of property due to which we feel like this. In the same way, in the reverse way, if you look at, जब आप बस में बैठे हैं, जब बस चल रही है, राइट? So आप स्टेबल कंडीशन में बैठे हुए हैं, बस चल रही है, कार चल रही है, vehicle which is accelerating or moving. The moment brake is being applied, you feel that you moved forward, you leaned forward. ऐसा क्यों होता है? क्योंकि as soon as brake is applied, आपका lower part it stops, but upper part is in tendency to move, because inertia tells that change of state of motion is not allowed. It is a property of the body, property of everybody. So हम फील करते हैं जैसे ही लोअर पोर्शन रुक जाता है, अपर पोर्शन इज इन मोशन एंड you feel that you are moving forward. This is the effect of inertia of an object. With example, I think inertia concept is clear. So inertia is of three types. First, inertia of rest. Second, inertia of motion. Third is inertia of direction. अब ये समझना है कि इन तीनों का मीनिंग क्या है. Inertia of rest, inertia of motion, inertia of direction. Right? Inertia of rest means if the object is at rest, then it tries to maintain its state of rest. Right? So that is called the inertia of rest. When the object is in motion, so it tries to maintain the state of its motion, and that is called the inertia of motion. Motion along a straight line, right, with constant velocity. It tries to maintain that, right? That is called inertia of motion. And third one is inertia of direction. So along a straight line it is moving, direction is maintained, magnitude of velocity is maintained. There is no change, right? It tries to maintain that. If due to inertia these things are being maintained, if it is to be changed, then some external unbalanced force will have to be applied. Otherwise it will maintain its state of motion. And any force, anything we are going to do, it opposes. Even if we are going to change the direction, due to inertia it opposes that cause, right? Force is being applied, it will oppose. So that is inertia, and inertia concept is clear. So we will talk about another physical terminology, that is momentum. Momentum होता क्या है? Momentum is denoted by P. It is a vector quantity, that is why I have put an arrow at the top of the symbol. Momentum concept को समझने के लिए इसको यूं समझो, एक object है. There is one ball of mass m, another ball of mass capital M, and capital M is greater than small m. Suppose इस तरह का situation है, and this ball is moving with velocity v, and this is also moving with velocity v. एक बॉल को फेंका गया है velocity v से, दूसरे बॉल को जो heavy है, right, heavier than this one, ये भी same velocity से फेंका गया, and you are asked to catch it. अगर आप उसको कैच करते हैं, तो किस बॉल से आपको ज्यादा चोट लगने की संभावना है? तो ऑब्वियसली आप बोलेंगे तो हेवियर बॉल, राइट, इससे चोट लगने की संभावना ज्यादा है. चोट मीन्स व्हाट, कि जो हम फोर्स लगा रहे हैं, दैट फोर्स विल बी मोर टू स्टॉप इट. अगर हेवी मास है एंड लाइट मास है, दो बॉल, एक हेवी है, टेनिस बॉल है, एक कॉर्क बॉल है, सो जो हेवियर बॉल है इसको स्टॉप करने के लिए ज्यादा फोर्स लगाना पड़ेगा, मींस चोट लगने की संभावना ज्यादा रहती है व्हेन वेलोसिटी से, राइट. दूसरा केस इस तरह से लेते हैं कि दो बॉल हम लेते हैं, एक सेम एम एंड दिस इज अनदर बॉल, सेम बॉल विद द सेम मास. इसकी वेलोसिटी v1 है, इसकी वेलोसिटी v2 है, एंड v2 इज ग्रेटर देन v1. अगर ये सिचुएशन, दो सिचुएशन लिया हमने, यहाँ मास वेरी किया, वेलोसिटी सेम लिया, यहाँ मास सेम है, बोथ आर हैविंग सेम मास, ए भी एम है, ए भी एम है, वेलोसिटी डिफरेंट है. अब इसको अगर कैच करना है आपको, तो किस बॉल से आपको ज्यादा चोट लगने की संभावना है? तो आप बोलेंगे इसका वेलोसिटी ज्यादा है. इट मीन्स द फोर्स विच इज hitting your hand, or you are applying force on the ball, it depends on two factors, mass and velocity, right? If mass is increasing, this force is increasing. If velocity is increasing, having the same mass, then force is increasing. अब देखिए, आपने ऑब्जर्व किया होगा, जो क्रिकेटर्स रहते हैं जब कैच करते हैं तो इमीडिएटली से होल्ड नहीं करते, इसको थोड़ा सा ऐसा करते, हाथ पीछे करते, राइट, हियर टू हियर. So what do? They extend the duration. वेलोसिटी जीरो करने का जो ड्यूरेशन है फ्रॉम हियर टू हियर, हाथ को टच हो गया, उन्हें डिस्टेंस बढ़ा दिया। सो ये ड्यूरेशन बढ़ाते हैं, तो ड्यूरेशन बढ़ाने से वो फोर्स कम लगता है। इट मीन्स एज वी इंक्रीज द ड्यूरेशन फ्रॉम हियर टू हियर, ये फोर्स इंपैक्ट कम आता है, राइट। सो हियर important factor is the combined effect of mass and velocity of an object is called the momentum. So momentum is equal to momentum P, it is a vector quantity, is equal to mass into velocity. ये इंपॉर्टेंट चीज है, कंबाइंड इफेक्ट ऑफ मास एंड वेलोसिटी। मास बढ़ता है, मोमेंटम बढ़ता है, वेलोसिटी बढ़ता है, मोमेंटम बढ़ता है, एंड कंबाइंड इफेक्ट ऑफ दीज टू बिकॉज दे आर डायरेक्टली प्रोपोर्शनल। मोमेंटम कंसेप्ट जो है द प्रोडक्ट ऑफ मास एंड वेलोसिटी, एंड द डायरेक्शन ऑफ पी इज सेम एज दैट ऑफ वेलोसिटी। जिस डायरेक्शन में वेलोसिटी है उसी डायरेक्शन में मोमेंटम होता है। अब इसके मैग्नीट्यूड की अगर बात करेंगे, so therefore magnitude is P, that is equal to m into v. This is by magnitude, this is in the vector form, and the direction of momentum is same as the direction of velocity. मोमेंटम का डायरेक्शन वही रहता है जो वेलोसिटी का डायरेक्शन रहता है। सपोज एक ऑब्जेक्ट है, मास इज 2 kg, मूविंग विद वेलोसिटी 5 meters per second, then what is the momentum? So momentum I will say P is equal to m into v, that is 2 into 5 meters per second, that is 10 meters per second, that is momentum, right? So with this example also we can understand. So many things about the force we have understood. What the force is, what are different kinds of forces, what is balanced and unbalanced forces, what is inertia, what is momentum, all these things are understood. So I will talk about Newton's first law. From here onwards, for application of force will be looked at. Okay? So Newton's first law. First law tells that every object tries to maintain its state of rest or of uniform motion along a straight line until and unless an unbalanced force is applied on it. What is the significance of this? You see, every object tries to maintain a state of rest or of uniform motion along a straight line until and unless an unbalanced force is applied on it. Means, if an object is at rest, it will remain at rest. This is inertia, due to inertia, property of an object. And if it is in motion, uniform motion along a straight line, it will try to maintain its state of uniform motion along a straight line unless and until an unbalanced force is applied on it. What is the significance? If F net is equal to 0, if net is equal to 0, means total force is 0, there is no unbalanced forces applied, means forces are balanced. In that case, what happens? Acceleration will be 0, right? Acceleration is 0, means two cases are there. When I talk about acceleration is 0, so it will be rest or uniform velocity. Not, it is uniform velocity, not the uniform speed. Uniform velocity or rest. These two conditions means A is equal to 0. These two conditions are here. either object is at rest or uniform motion along a straight line. Along a straight line means uniform velocity. Magnitude is constant and direction is constant. That situation is called uniform velocity. So if net is 0, acceleration is 0, that is the meaning of first law, or Newton's first law. It is called the law of inertia also. Law of inertia. Why it is called law of inertia? Because this situation is due to the property of an object, that is inertia. Just before this I explained you. Due to inertia, every object tries to maintain its state of motion. When I talk about state of motion, means I am talking about its velocity, right? So first law is clear. So this can be understood by this situation is called the equilibrium situation, right? Equilibrium. And equilibrium condition. This is the condition of equilibrium condition. When their object is at rest or in uniform motion. So equilibrium condition, this is also two types. One is static equilibrium. Static equilibrium means object is at rest. Object is at rest. When forces are being applied, a net effect of the force is 0 and the object is at rest, then I will say it is static equilibrium. Another is called the dynamic equilibrium. Dynamic equilibrium. This is situation the uniform velocity. The object has uniform velocity. Because in both the conditions, F net is 0. Either it is at rest or in uniform velocity. In both the condition F net is 0, then whenever F net is 0, means it is an equilibrium condition. So there are two types of equilibrium. One is static equilibrium, another is dynamic equilibrium. And static equilibrium means object is at rest, and dynamic means it is moving with constant speed along a straight line or with constant velocity, right? So I will give you an example to understand what is the equilibrium state is and how to find the rest of the forces which is acting on the object. Now this is a numerical problem I have taken. This is a sphere and these are the wedges, and angle 37 is given, this is angle 53 is given, and mass of this sphere is 1.25 kg. So find the normal reactions acting on the sphere due to wedges when it is in static equilibrium. Just I told you what is static equilibrium, that is the object is at rest, and we have to find the normal reaction on these sphere. So normal reaction, the surfaces are in contact. Before that also, what is normal reaction? Those surfaces which are in contact perpendicular to that surface is the normal reaction. So normal reaction acting on the sphere is in this direction. Normal reaction acting on this will be in this direction. Suppose this is N1, this is N2. So it is passing through center. As I told you, in case of sphere, disc and ring, if force is acting normally to the surface, then this will be passing through the center of the sphere. And this center is the center of mass, that will be discussed later. Whole weight will be acting downwards. That will be mg. So now it is in equilibrium, means net force is 0. Net force acting on the sphere is 0. I am talking about the sphere, not on the wedges. Here forces acting on the sphere is 0. Means if we resolve these forces, I told you sigma x is equal to 0, sigma y is equal to 0. Sphere is in static equilibrium, right? Therefore sigma fx is equal to 0 and sigma fy will be equal to 0. So at this point I will make this x-axis and this is y-axis, right? So this is the opposite direction, that will be minus x, this is positive direction. So इस तरह से है. अभी इसको हम सभी फोर्सेस को एक्स वाई डायरेक्शन में रिजॉल्व कर देंगे. सो mg को करने की जरूरत नहीं, इट इज अलोंग y एक्सिस, x एक्सिस के डायरेक्शन में कंपोनेंट इज 0. सो हम रिजॉल्व करेंगे दीज टू फोर्सेस को, दैट इज नॉर्मल रिएक्शन व्हिच इज एक्टिंग ऑन द स्फीयर. सो सी, this is 50 degree, this will also be 53 degree because this is parallel to this is transversal, this will be 53. This angle will be 37 degree, so this will also be 37 degree. Similarly, if you extend, this is 37, this will also be 37 degree, right? This is 37 means this will be how much? Since it is 90 degree, it is acting at 90 degree. So this will be 53 degree and this will also be 53 degree. So this angle is known, this angle is known. So resolution of N1 and N2 is possible, right? So I will write Fx, sigma Fx in x direction. So component of N2 along x direction, that will be N2 cos 53 degree plus N1 in this direction, that is N1 cos 37, and that is opposite direction, that is minus N1 cos 37 degree. That is sigma x along x axis. I will talk about y axis. So sigma Fy, that is this direction is positive, so N1 sin 37 degree plus N2 sin 53 degree, because these components at both are acting in positive direction of y axis. This direction is positive, right? And this direction is negative. This is positive and this is negative. This is known, that you know already. So as we know, and this is positive and downward direction acting mg, so I will write minus mg, right? That is total force along x-axis, this is total force along y-axis. It is in equilibrium state, so this should be 0 and this should also be 0. If this is 0, right, but sigma fx is equal to 0, therefore n2 cos 53 degree minus n1 cos 37 degree, that is equal to 0. Therefore n2 cos 53 degree is equal to n1 cos 37 degree. So for 37 degree standard we know 37 degree, this is 53 degree, this is 3, this is 4, this is 5. So with this we can put the values, and this is n2. Therefore n2 into cos 53 for this angle, this is the base, this is hypotenuse, that is 3 by 5, that is equal to n1 into cos 37, that is 4 by 5, 4 by 5. So 5 and 5 will go, therefore n2 is equal to 4 upon 3 and 1. So first relation we got. We will get some relation from here also, then we will find n1 and n2. We will proceed further. Now, sigma Fy is also 0. Sigma Fy, that is equal to 0. Means n1 sin 37. So n1 sin 37 degree plus n2, that is sin 53 degree minus mg. M is 1.25. 1.25 kg into g is 10, that is equal to 0. आप सबके वैल्यूज रख देंगे. Therefore n1 sin 37 3 by 5 into 3 by 5 plus n2 sin 53 4 by 5 into 4 by 5 is equal to 12.5. I can say like this. Therefore 5 will go on this side, this will be 3n1 plus 4n2, that is equal to 12.5 into 5. This relation we got. We will further proceed, that we can write N2 is equal to 4 upon 3 N1. So in place of N2 we will write 4 upon 3. So we will write 3 N1 plus 4 into 4 upon 3 N1 is equal to 12.5 into 5. This is equal to how much? 9 N1 plus 16 N1 upon 3, that is equal to 12.5 into 5. It was 25 N1 by 3 is equal to 12.5 into 5. Therefore, 25 N1 is equal to, or simply N1 I will write 12.5 into 15 upon 25. So, how much it is? That is 0.5. Is 7.5 Newton. That is N1. Right? Therefore, N2 is equal to 4 by 3 into 7.5. This will go, that is 2.5. That is equal to 10 Newton. Therefore, N2 is equal to 10 Newton. So, this way, if it is in static equilibrium, so many things I covered in this, how sigma x, sigma fx and sigma fy is 0 in case of state of equilibrium, and Newton's first law is applied because it is not in motion, right? So unbalanced force is 0. That is why it is in static equilibrium. Since it is not motion with constant velocity, it is in static equilibrium. So we have to find the forces, some forces, and taking the condition of sigma fx and sigma fy is equal to 0. So this way I have taken a Newton's first law, and we will meet next time. Till then, stay safe, be happy, be sincere, and take care of you. All the best. All the best.